for this problem now, we'll find an expression for this distance y2 that also has a q and an m in it. So y2 is the distance it travels as it's going between here and here. So we'll write down our kinematics equation again. y2 is v0 to y times t2 plus 1/2 times a2 times t2 squared. So v0 to y, that's the y component of the velocity of the mass when it's right here. So when it's right here at this point, it has a velocity v02. That's got a y component and an x component. The x component here will be the same as the x here because there's no acceleration in the x. The y component here we'll find using a kinematics equation because the y component of this velocity is the final velocity for path 1. So the y component of velocity right here is equal to the initial y component of velocity plus the acceleration when it's in this region times the length of time that it's in this region. So that's 0 plus our acceleration we wrote up here minus q over m times 800. So our initial velocity is 0, there's our acceleration, and then we'll also multiply by the time t1, 5.2 times 10 to the minus 5. And what we get for that velocity is that it is minus 0.0416 q over m. And for our time t2, okay, oh, and we had our minus up here as well. We dropped that part, the minus from q over m should be right there. For our t2 part, we'll find t2 similar to how we found in the first part. It travels a horizontal distance. When it's in the second part, going from here to here, it travels a horizontal distance of 56, and it has a horizontal velocity of v0, which was 5 times 10 to the 3 meters per second. So we can find our t2 no problem. So x2 equals v0x times t2. So then t2 is that distance x2, 0.56 meters, divided by the speed, 5 times 10 to the 3 meters per second. Gives us a t2 of 1.12 times 10 to the minus 4 seconds. So next we have our A2. When it's in this area, we're assuming that we're going to neglect gravity, which means there's no acceleration because there's no field here, so our acceleration is 0. So we'll put in this for our speed, this for our time, and we get that y2 is minus 0.0416 q over m times 1.12 times 10 to the minus 4. Put that through the calculator and we get a y2 portion of the path, 4.6592 times 10 to the minus 6 times q over m. Here in this problem I'm keeping some extra sig figs because I don't want to round ourselves out of the answer. So now let's put y1 and y2 in over here. So y1 is minus 1.0816 times 10 to the minus 6 times q over m, plus y2 minus 4.6592 times 10 to the minus 6 equals the distance d that goes down, it's negative, minus 1.25 centimeters. We'll just put that in meters. Then we can solve for q over m, and what we find for q over m is that we get 2,180 coulombs per kilogram. So that's the charge to mass ratio of that little charge.